And welcome everybody to the Daily Space Weather. This video was originally streamed live to Twitch because of the pathetic censorship of YouTube. Look for more and more live streams coming from us on Twitch. It is simply a superior platform. The censorship isn't as sickening as it is on YouTube. So again, this was originally streamed live to twitch.tv/smAsho. We've got a spectacular coronal mass ejection and prominence. Some of the plasma collapsed back onto the corona and or chromosphere as well. But ultimately fairly low levels of activity. We've got a coronal hole wind stream headed our way and lots more to cover. Let's blast through it. Here's some more spectral analysis of the closest star. This is 94 and 171 angstroms together, two different ionized iron spectra. Some great wavelengths there. We've only got two named sunspot groups when we did show prep. And you can see how magnetically unorganized the sun is at the moment. Not a lot of sunspots or anything like that. There is a high-speed coronal hole wind stream headed our way. This sunspot here degraded since yesterday. This one here's got a bit of an odd magnetic orientation. You've got the sunspots at the umbrae are here at a north and south orientation to each other. So they're lined up like this, actually. Instead of around the same latitude, they're at different latitudes. I guess that's noteworthy. Let's continue on. And here you can see barely any dark spots there. There are sunspots, but just hardly. The radio flux is only at 85, so again, quite low levels of solar activity here. Here's the one-year chart to put that in context. The black line there is the radio flux. And let's go to the Space Weather Enthusiast dashboard here to see only a brief period of geomagnetic unrest forecasted for early in the day tomorrow. Again, there is a high-speed coronal hole wind stream headed our way. We can expect a major intensification in the solar wind density, followed by a dip in the density and an uptick in the speed. Global seismicity is just at fairly low levels here. That's the 90-day bar graph of global earthquakes, showing only major quakes. So nothing above a 5 magnitude range. There was a 5 in Mexico, as well as in Papua New Guinea. Besides that, pretty unnoteworthy. And if there's something you'd like us to cover, just leave us a comment. And we will be checking your chats on Twitch. We won't be displaying them on the screen in this video. But leave us comments regardless of what platform you're viewing on. So we've put the video on Twitch, on BitChute, and on YouTube. These Daily Space Weather videos have been YouTube exclusives, and that has officially ended because of the pathetic censorship of the YouTube, quote, platform, end quote. It's a platform, all right. The kind of platform that you're standing on before you're hanged. Let's check volcanoes. There is a massive ice sheet which is losing altitude as it melts from underneath Grimsvötn. Grimsvötn in Iceland. The meltwater has reached a level of 4,000 cubic meters per second. So an incredible amount of water coming out of this ice sheet. A glacial flood expected to reach its peak on Sunday. And it's already subsided about 27 meters. Also higher than usual gas emissions detected at the glacier rim of the volcano. So perhaps a large volcano about to erupt there, who knows? We'll be covering it daily. La Palma continues to explode. It's producing a 7,000-foot plume of ash and probably some new real estate. Subanose-jima, flight level 060. It's a 6,000-foot ash plume over the Ryukyu Islands. Indonesia, on the Isle of East Java, there's a volcano called Semeru there, which has produced a 40,000-foot plume of volcanic ash. That is probably the world leader there. That's the biggest volcano on Earth. Semeru, on the Isle of East Java, producing a flight level 400. Don't attempt to pole vault that caldera. It could be unhealthful. Samisa Pochnoi, low-level emissions over the Aleutian Islands. Popocatépetl exploding. Flight level 200. A 20,000-foot ash plume's been produced over central Mexico. Fuego, volcanic ash, has dissipated or dispersed in the satellite imagery for Guatemala. Nevado de Ruiz, exploding 22,000-foot ash plume over Colombia from Nevado del Ruiz. Sangre. Activity has been increasing over the Ecuadorian volcano Sangre. Click on read more here. A swarm of long-period earthquakes and a new lava flow at Sangre. Also in the country of Ecuador is Revenador, flight level 160. As Revenador explodes, it's a 16,000-foot ash plume. Sabancaya exploding, flight level 240. 24,000-foot plume of volcanic ash over Peru from Sabancaya. Nevados de Chilean exploding, flight level 120. It's a 12,000-foot plume of volcanic ash. Don't forget to enter the promo code FINISHLINE by visiting the links below the video to our Redbubble shop. You can also find the link to that at smAsho merch from the homepage smashomash.com. Promo code FINISHLINE to save 25% through December 7th. So again, folks, do not pull Volta Caldera, Universum Liberate. Tell your friends and foes about us. We make just this side of nothing to put this content on YouTube, and so you gotta do what you gotta do for basic survival. Congratulations on realizing that the channel exists. Somehow we don't seem to think the algorithms have been helpful. Of course, there's probably some demand for our content, and we keep our opinions at the low level here in the Daily Space Weather videos. Opinions expressed in these videos, not necessarily the opinions of Smash News Network, Least Busted, Name and News. Let's get back to it. Welcome to the Renaissance. Please visit the homepage smashomash.com. Become a subscription member at the Smash team. There are two levels, two basic levels, $2.99 and $9.99 per month, as well as a paid-up annual option. You can find a link to the Smash team and the Smash merch right there at the homepage, smashomash.com. Again, welcome to the Neo Renaissance. We're going to show you a little teaser here on our latest post at the Smash team. It's only for gold level members. So we're going to show you just enough here that you won't know what the post is about. Have you heard me suggest in just a few years electricity will be essentially free? Find out more about that by becoming a gold member at smashomash.com/smashteam. Next, we're going to get into some magnetic data here. First, the GOES magnetometers. The GOES 16 and 17 are measuring magnetic fields from their equatorial geosynchronous orbit. And we're seeing some wild spikes here. Another indication that there's a huge plume of plasma on the way to Earth. It's a coronal hole wind stream. We can expect it in a couple of days. Also, we made a forecast yesterday about the heliospheric current sheet. We said the South Pole current sheet is going to be delayed, and as you can see here in the last image, South Pole current sheet is nowhere near even stereo A yet, so there's another correct forecast. Our forecasting on the channel is ridiculously accurate, and if you don't believe me, go watch our older videos. You'll find a timeline of reality. So, by the way, this data is from 51 ground-based magnetometers. It's the National Sunspot Observatory. Also magnetometers on stereo A here at Lagrange 5 and stereo B at Lagrange 4. Here's a line-of-sight view of the heliospheric current sheet. Also the solar magnetogram showing up there. Most importantly, the story is coronal holes because there's a massive plume of plasma emanating from this one, which is headed our way. And the South Pole field here has shrunk back down. We've got another North Pole-oriented coronal hole here on the last frame. You can see right up here, rising in the northeast there, more North Pole-oriented coronal hole. I'll let that play through one more time for you here before we show a great visual of this. Here's 193 angstroms from the SDO. So that's a pretty well-defined coronal hole there. We can, again, expect some geomagnetic effects from that, perhaps a geomagnetic storm, maybe a KP5 event, something like that. If you've got guesses as to what the solar wind speed will reach, leave us a comment and let us know. We've also brought up some different spectral images here. This is 1700 angstroms as well as 193. There is a bit of a synchronization problem there because of missing data from the one wavelength versus the other, but it does show you essentially the surface of the chromosphere. That's the 1700 angstroms view. I just wanted to show you that because it shows you the coronal holes as well as the surface of the closest star. Likelihood of solar flare still at about 30%. And yesterday I said we could see an M-class flare. We did see a significant C-class intensification. We're going to be down to only one sunspot group here today. It's going to be 2902. There are no other ombre visible, at least when we did show prep. We could still see an M-class flare out of that. 2898 will lose its name today, as it's just about to set. It'll probably be set by the time we're done streaming. Here's the flaring profile, and you can see there was a significant flare here. It's only a C-class. Peak flux there was around 5:10 universal time this morning, and associated with a coronal mass ejection, which we showed you earlier in the video. So here's the proton flux. No spikes there, no relativistic particles, no major flares have flung protons in our direction. Next, we're going to show you the real-time solar wind. Pretty unremarkable here over the past 24 hours. There was a small intensification in the solar wind speed here, nothing major. Current solar wind speed about 476 kilometers a second. Solar wind density pretty diffuse here at 5.48 protons per cubic centimeter. Again, we can expect some major shifts in this in the next day or two from a coronal hole wind stream. KP index, a measurement of global geomagnetism, is at 1. It's a geomagnetic calm condition. Here's the magnetic moment from space over the past 4 hours. And we're not expecting any fireworks here at the moment. Not for a couple days at least. And that refresh, we're going to let that play through. The scale you're looking at in this model, by the way, is nanopascals, which is magnetohydrodynamic pressure. Again, that's the last 4 hours of Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. And here is Earth's magnetic moment from the ground level in nanotesla magnetic flux density. Ground magnetic perturbations, changes to Earth's B field, known as geospace delta B, from the surface of the planet. No major changes here, although when we have these calm, homogeneous conditions, perhaps it's giving us some insight into Earth's internal structures. In any case, like the last frame, that's 4 hours of data. Next, we've got a diagram of the solar system. Happy new moon to all you reverse werewolves out there. Congratulations on sleeping well at night and not becoming cannibals and being generally productive and useful members of society. Cheers to all you reverse werewolves. Let's do a forecast. There's where things will be in a week. We'll be moving into a gibbous waxing mode in 7 days. Next, a star chart. And you can see the galactic plane here shown as a blue line. The ecliptic shown as a yellow line. That's the path the sun will take across the sky. We've got Mars, the moon, Mercury, and the sun all piling up here in the southeastern sky in eastern Pennsylvania. We're located in Lehigh Valley, if you're wondering. And let's take a look at this coronal mass ejection. We're going to show you the view from Lagrange point 1, the location of the LASCO C2 and C3. So the SOHO spacecraft has got 2 coronagraphs on it. And there they are. You can see that coronal mass ejection likely to miss the Earth here. Also seeing Mercury here on the LASCO C3. A great fireworks display. This is not done propagating yet, so there could be an Earth-facing component. But at the moment, this looks all like it will miss to the southwest. If I had to guess, which I certainly don't. Again, we're paid just this side of nothing to put the videos on YouTube. Today's cosmology segment is nothing more than an ad. If you haven't checked out our playlists, we've got playlists over at the pathetic platform, youtube.com/smashamash. And one of our playlists is indeed cosmology segments. So check those out. Again, youtube.com/smashamash/playlists. And today we're not featuring a random number. There is the astronomy picture of the day. It's a nighttime sundog. It's a bunch of ice crystals causing a prismatic effect. No more on that. Putting more on and more on that is not what happens during our cosmology segments. Let's check charging hazards. And we don't see any charging hazards at the moment. Let's move on to the electron flux. Here's the greater than 2 mega electron volt electron fluence. This is measured by the GOES 16 and 17 in their geosynchronous orbit. They're endeavoring to measure this at the F ionosphere layer using radiography. And there is the 3-day chart from the GOES 16 and 17. For you new viewers, these N's and M's mean noon and midnight local time for the satellite, giving you some indication of the location when the measurements are being taken. In other words, they're basically on the opposite side of the planet from the sun right now, a situation which gives them lower readings typically. And here's the forecast model for relativistic electrons. Expecting flat levels here, which means we'll probably get back into warning levels a bit again today. No arguments there with the NOAA forecast. We will see this crater when the coronal hole wind stream arrives. Next, we're going to show you the total electron content, which is the source for the likelihood of GPS errors. And the redder this gets, the more likely you are to have a GPS error, as your GPS handset must communicate with a satellite at like 12,500 miles of altitude. If there are a lot of electrons in between you and the satellite, you will see massive errors. I've seen errors of about 1,000 miles here in Pennsylvania, where my GPS thought I rode to Missouri and back in 40 minutes at an average speed of 10,000 miles per hour. That's why you turn on location accuracy if you're around the equator at noon especially. Next, we're going to show you the F ionosphere layer. Here's the ionogram from about 300 kilometers of altitude, the location of the F ionosphere. We'll also show you the anomalygram. Just give that a quick minute to load. There you go. There is the F ionosphere layer. It's showing you vibrational frequency here. This data is courtesy Australian Government Bureau of Meteorology. We hope they're doing a better job than the Australian Government Bureau of Virology. And we do see some anomalies, and rather than try to explain where they are, we're just going to show you the anomalygram. Here's the anomaly in megahertz from the 30-day median. So we've been seeing some pretty wild swings here in the ionosphere. Those have been continuing. So once again, quite a bit of anomalous ionospheric vibrational frequency happening, giving us insight into things like the Earth's magnetic field. Anyway, here's the latest image. That's 12:45 Universal Time. Pardon our lateness, but we changed the format for a very specific reason. And again, just to reiterate, it's because of the pathetic and putrid censorship at YouTube.com. Yeah, YouTube. They're unnecessarily censoring people with pathetic algorithms, aka junkware, which make no sense. All right, let's get me off the screen here and get to our bonus features. All right, folks, so the first bonus feature we're going to show you here is the latest ground-based solar observatory data. So we're going to show you El Teide, Spain. It's probably going to show you a coronal mass ejection in the southwestern limb. El Teide, Spain. This data only 3 minutes and 42 seconds old. Can we see a filament eruption? Not so much. Let's continue on to show the latest intensitygram and the latest magnetogram. Check it out. Those sunspots are out of view. And this one is still beta class. So we've got two opposite polarity fields here. And the likelihood of producing flares is the highest in that region. That's a sunspot too. So we still do have two named sunspot groups at the moment. Besides that, and there are the fields of that beta class sunspot. That is still only an alpha class sunspot. And let's close out today's daily space weather with... Actually, let me check the life of the stream once again. And everything looks A-OK. So here's my favorite wavelength, 171 angstroms. Just spectacular imagery there from the Solar Dynamics Observatory. And here's the classic 304 angstroms ionized helium. You can see this filament migration happening over here as well. Likely collapsed back onto the sun because we didn't see any coronal mass ejection associated with that. You can just see the initial propagation of this filament eruption down here. Anyway, thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.